И с первым докладом у нас выступит Дэвид Томаси, представляющий Италию на нашей сегодняшней конференции. Он окончил аспирантуру по философии в Софийском университете в 2015 году. Его тема диссертации «Медицинская философия. Анализ самовосприятия». И исследует направления смежной философии, медицины и психиатрии. В настоящее время является преподавателем психотерапии, этики и нейронаук в университете Вермонта и практикующим психотерапевтом. Я думаю, что передаем ему слово и, да, готовы послушать его доклад. David, we are back to you and ready for your speech.
Большое спасибо. All right, great. So I think I have about 10 minutes or so I'll be fast and to the point. Well, thank you very much for giving me the chance to talk about this fascinating topic, a topic that never ceases to amaze me and my colleagues. The title is The Neuroscience of Near-Death Experiences and Out-of-Body Phenomena. Before we start, let me just share that there's only so much we can actually say about these two phenomena, simply because the modalities of neuroscientific investigation we use are predicated upon everything else we know about thoughts, emotions, and behavior. So let's begin with the first slide, please. Thank you. So as you can see here, this is an image of an fMRI, functional magnetic resonance imaging techniques. And one of the features of these techniques is that it gives us a very good understanding of both function and structure in the brain. More specifically, how things work as they work simultaneously at the same time in which we are investigating that. And they also provide a very rich picture in comparison to other techniques, for instance, EEG, electroencephalograms, that focuses more, as the name implies, on electromagnetic function and waves, so spikes of action potentials. Let's continue, please. All right, so just a general image of two diagrams of the brain, two sagittal diagrams of the brain, one from the top of the brain and one from the bottom of the brain, with added descriptors in colors for different macro areas of the brain. Now, why is this important? For a variety of things. First of all, because when we look at the brain, the assumption is that we are looking at neural underpinnings. So in this slide, you see a general title, function either smaller or equal or bigger and equal, or at the very least equivalent to structure. And this is one of the biggest debates in neuroscience. I would say it's an ontological debate, but at the same time a phenomenological one. Why is that? Well, because some neuroscientists believe that the function of certain brain structures are the results of the structure. So, for instance, to give an example, the fact that a straw allows us to drink some liquid is predicated upon the fact that the straw shape and form is the best form to do that task. Other neuroscientists instead believe the opposite, that it's actually the function itself that determines the structure. For instance, if you're thinking about breathing mechanism, inhalation and exhalation, we could make the argument that from an evolutionary biology perspective, lungs are the result of this process, the process of respiration, over 100,000 of years. Now, of course, this is kind of the chicken and the egg problem, which one came first. It's something that we might not be able to answer. Now, the slide says, observing neural underpinnings is predicated upon the theoretical assumption that something underlies something else, possibly with causal factors. The debate around function and structure is akin to the one between mind and matter. So it's the hard problem, as we say in philosophy, the hard problem of consciousness. It is ontological and phenomenological in nature, and its presupposition ultimately determine what evidence we consider as self-evident. So every time we talk about something that appears to be, for lack of better terms, transcendental, very often we might encounter the risk of either embracing it or rejecting it because it sounds like too spiritual. And of course, this is a risk in neuroscience because on one side, we might be prey of trying to demonstrate something that it's beyond the scientific method, beyond what we can observe. And on the other side, we might reject the whole perspective altogether, like in tossing the baby with the bathwater. So the idea here is something is below, behind, or at least underneath something else. Now, I will not spend too much time on this slide specifically, but for now, let's just take a look here. Even from a purely empirical, aesthetic perspective, what we can perceive our senses, we could make the claim that it's much easier to see something from above than see something from below, neuroscientifically speaking. And as we will see, a lot of these technologies don't really give us the same amount of information, whether we're talking about cortical structure, okay, higher functioning element, as opposed to things that are found in the brain stem. So, right below this image here, you can really see it well at the central part of the right figure, the one from below. And of course, the brainstem, it's the area of the brain that's connected to all those fascinating areas, the pons and the medulla oblongata. Next slide, please. All right, so here's some image. And before I mention anything here, I want to admit my bias. Of course, in my field, I mostly study neuroscience, neurosurgery, medicine, psychology, psychiatry. And so some might already argue against that in a presentation on philosophy, a presentation on ontological elements, on the essence of things. Even if you embrace an existence over essence perspective, you might argue against me because you might say, well, there are things that we cannot demonstrate empirically, and whether you are a continental philosopher or an analytical one, you might criticize me because I'm just showing images from lab research, but this doesn't really say anything about the theory behind it. And you'll be absolutely correct in doing that. So let me do my best to see why I think neuroscientific research, and more specifically brain imaging, is at the very least important. Now here we find 4 different images. Conscious control on the top left corner, and that is pretty much, as in any other case control studies, the basis against we discuss everything else. I see there's a bit of feedback on the audio. Let me see if I can maybe turn off my mic here. All right, hopefully this works a little better. I'm not quite sure. I'm gonna also turn off this for now.
Yes, we hear you well.
Okay, thank you. So conscious control is pretty much the normal person, so to speak, a person with full capacity of cognitive processes. Okay? And it's almost irrelevant in this context how intelligent a person might be. We're talking about quantitative data, mathematical data that we relate to consciousness, so to function. Not necessarily higher function, but definitely high cortical function, so executive function, we would say, in neuroscience. Then on the top right, you have vegetative state. And as we will see, vegetative state is a very good descriptor of what the word means. So we are reminded of vegetables. And of course, our assumption is that vegetables are in no way as cognitively strong as we are as human beings or as animals in general, especially mammals. Then down below, bottom left, we find locked-in syndrome, or LIS, which I will discuss in a few seconds. And finally, top right, minimally conscious state. Now, even if you're not quite familiar with all those areas, the idea is that the least amount of cognitive function, the least amount of color, all right? And the other thing that you might look here in terms of the scale, from red on top to purple, blue on the bottom, is that specific area seems to be more involved with the processes, which might sound a little counterintuitive here, because most of the time when we talk about function of cognition and veto power control and moral judgment, we tend to think about the front of the brain. So we talk about the prefrontal cortex. And while the prefrontal cortex is certainly, highlighted here in green, you can see there's a lot of movement here in the parietal lobe, and even more so as we will see in the occipital lobe, the bright red area. Next slide, please. So LIS, or locked-in syndrome. Let me read it and then I'll explain super quick. This was a term first used, at least in the English-speaking world, by Fred Plum and Jerome Posner to indicate a subject being isolated due to quadriplegia and pseudobulbar palsy, albeit having awareness, sleep-wake cycles, and clinically meaningful behavior. In a specific case, the syndrome is classified as either a total locked-in syndrome, TLIS, or completely locked-in state, CLIS. Of note, in locked-in syndrome, the eyes of the patients are paralyzed as well. So when we say that someone is locked in, at the very least, we are implying that this someone is different from the body that contains them. And so this is already to some extent, a dualistic perspective. We are different than our bodies. Our mind is different from our brain. So I don't think many neuroscientists are aware of that, philosophical, theoretical assumption they make. I think it's a correct one. I'm not sure if I would, fully label myself as dualist in that sense. I would probably label myself more of an interactionalist. And so just because two things communicate, it does not imply that one is predominating, so to speak, at the very least in terms of the scripture. Now, what you can see here in the image right next to it, this is an image of the ventral pons. I mentioned the importance of those areas at the level of the brainstem. And what is important? Well, aside from the fact that this specific image is related to a stroke, because in children, locked-in syndrome is mostly caused by a stroke in the ventral pons. But in any case, any area that connects the pons, the medulla, and the brainstem, it's really hard to investigate, neuroscientifically speaking. It's very hidden. It's seldom the case you can do anything very precise with fMRI, and certainly not with EEG, as the name implies. You cannot really detect that. But some of you might argue, well, it's just a question of time. As the technology develops, we will be able to tell more about the brainstem. But the point I'm trying to make here, briefly, is that regardless of how much evidence we find for those functions, it doesn't really say anything about the nature of near-death experiences or out-of-body experiences. And the reason why I put these three things together, this comatose state, this locked-in state, this partial unaware cognitive function, near-death experiences, and locked-in syndrome, as well as out-of-body experiences, is because very often the physiological theories are very, very similar. Next slide, please. All right, so minimal conscious states. Same thing here. I will not spend too much time. I want to be mindful of your time here on each of these slides. But the most important thing here, I'm going to read from the slide. In this state, the patient has intermittent periods of awareness and wakefulness and displays some meaningful behavior, i.e. demonstrating purposeful or voluntary behavioral responses to auditory, tactile, visual, or noxious stimuli. So the risk is always to be biased here. What constitutes meaningful behavior? Is it a behavior that is meaningful in a moral or ethical sense? Certainly not, or at least this is not the condition sine qua non for that. It's simply a response mechanism to tell that the person is quote-unquote there. The tricky thing here is the temporary state. Again, intermittent period of awareness and wakefulness. This is extremely important from a, I would say, existential point of view, but also with legal and clinical implication, because the person might be there and might be not there if the only parameter we use is how much they respond. So this will be also a very big philosophical debate that we'll leave aside from now, that will justify where the person goes when they are experiencing this near-death or out-of-body experience. Now, this does not have to necessarily indicate anything transcendental, spiritual, or religious, but it still begs the question, if the person is not responsive, where is the person? Where is myself when I am, for instance, recovering from a post-surgical operation? Even in anesthesia, where am I? Next slide, please. All right, PVS or PCS. This is a diagnosis that is more intense, as the slide implies it lasts longer than a few weeks, with no evidence of sustained, reproducible, meaningful behavior, as well as no evidence of language comprehension and or expression, which is, again, might be a evolutionary biology speaking, a modern bias that language expression is the best descriptor of who we are. And yet again, it's hard to argue against that because animals do not possess that. At least they do not possess that in the same way as we do. So language and language expression seems to be something that makes us human in a very peculiar way. Intermittent sleep-wake cycles, sufficient preservation of autonomic functions to permit survival with adequate medical care, bowel and bladder incontinence, variable preservation of cranial nerve and spinal reflexes. And then subjects in this state are not aware according to 3 factors. Again, this is where philosophy and neuroscience comes together. We observe the baseline, and we see what's different in those cases in comparison to a normal functioning brain. Somewhat arbitrarily, but also something that seems to be quite consistent. A, the presence of stereotypical ocular, facial, and motor movements seen only with the destruction of higher cortical structure, accompanied by the absence of any voluntary movements. So, in other words, those functions and structure are combined and be completely deleted, so not allowing any response as a result of that damage. B, PET studies, so PET stands for positron emission tomography, PET studies that show decreased glucose metabolism in these patients. Yet again, when we talk about neuroscience, we're not talking only about electricity or electromagnetic function, but we're also talking about chemistry. And finally, C, postmortem autopsy studies showing extensive structural damage that is probably incompatible with consciousness. All right? Probably, that is the key. Again, we don't know where the person is. At the very least, we cannot make the case that the person at this point is equivalent with the body. Now, regardless of your philosophical stance on this, to make that equivalence will make it a false equivalence because, again, something is either there or it's not there. And even if you want to take into account partial, quote unquote, being there from a quantitative mathematical function, the fact that something can change is pretty indicative of the fact that something can, at the very least, not being fully there. And if it's not fully there, yet again, where is it? Next slide, please. Now, I will speed up a little bit because it's almost time. 2 more things. One is chronic coma, which is just coma. And again, lack of consciousness in sleep-wake cycles, etc., etc. And the last word here, the last sentence, and to respond normally to stimuli such as light, pain, and or sound. Now, the image simply shows brain connectivity in pathological and pharmacological coma, which again is connected to the fact that we can simulate certain states, chemically speaking. Next slide, please. It's the very last one. I will go back to the chemical part. Brain death. So again, if a neuroscientist or a physician might not be interested in philosophy or might not be interested in deep philosophical discussions, maybe because they don't see the value in it, or maybe because they feel it's almost counterproductive in a field where you need to be very much hands-on and solve problems. Well, at the very least, we have to decide what constituted death from the perspective of medicine. And brain death or heart cardiovascular death are usually the 2 pathways. Brain death even more so, simply because even from a materialistic perspective, the brain appears to be the central relay of everything else. And plus, the heart keeps pumping for like 3.5 hours after brain death. So it's a clinical, medical, ethical, and legal definition. So the physician is to observe the patient and provide a certification. I will read super quick from this slide. The certification should include 1, identification of history or physical examination findings that provide a clear etiology or causal factor of brain dysfunction. 2, exclusion of any condition that might confound the subsequent examination of cortical or brainstem function. Now, you probably noticed this to be somewhat of an oxymoron. I exclude what doesn't make sense according to a previously agreed upon definition. So it's something arbitrarily, despite the fact it's empirically observable. 3, Performance of a complete neurological examination, including the standard apnea test and 10 minutes apnea test. Again, oxygen, as we will see, is fundamental. 4, assessment of brainstem reflexes. Clinical observations compatible with the diagnosis of brain death. Responsibility of physician, notify next of kin, of course, in a multidisciplinary treatment team. Interval observation period, repeat clinical assessment, confirmatory testing and certification, and brain death documentation. Now, to conclude, all of this are related to function, structure, chemistry, and some basic physiological explanation. So for the ones that do believe that near-death experiences and out-of-body experiences are more to do with material, physicalist elements, they tend to think that they are based upon things such as cerebral hypoxia or hypercapnia. And cerebral hypoxia is simply lack or total, partial or total lack of oxygen, and hypercapnia the opposite. It's an increase of CO2 retention, so the level of carbon dioxide is very, very high. And then there are also other things that are discussed. First of all, where it's located and what structure are stimulated. So many people, to conclude, during what we refer to as near-death experience or out-of-body experience things that we would otherwise categorize as maybe spiritual, maybe transcendental. Bright line, exiting a tunnel, seeing figures that might resemble, I don't know, like spheres or angels or beings of light, being, so to speak, melting to the world, becoming either super big or super small, not having a distinction between a conceptualization of self and the rest of the world, being connected to the world, a sense of love, appreciation, and empathy. And sure, there are psychological ways to try to explain away, but again, those brain areas that respond accordingly make a lot of sense as to why they should respond that way. More specifically, and I conclude, occipital lobe function for the things we perceive with our visual cortex. We see things despite the fact that, yet again, we are not responding in our body. So this is, again, not really easy to explain away in a materialistic perspective. Our eyes do not function, no oculomotor nerve, no optical nerve, and no cortical function to determine those responses to the stimuli, and yet we can still see. So there is an activation here. The other thing is the involvement of the pons, the brainstem, which again are not by definition higher functioning elements. So to claim that we react to certain things because of the way we've been raised or our culture or upbringing, it's really a hard claim to make. Plus, the same experiences are found by people that are coming from very different religious perspective, atheist and believer alike. So they all experience very similar things. So that in itself, it's no explanation. The fact that it could be a cultural factor. And finally, and perhaps most importantly, the activation of hippocampal structure. And the hippocampus is related not just to perception of emotions and intense empathetic elements, but more specifically to memory, including biographical memory. So claims that you might have heard about people that feel that they experience past lives, or at the very least an earlier stage of their development when they were children, and they see other things, seem to be quite consistent neurologically speaking with those findings. So to conclude, can we claim that out-of-body experiences and near-death experiences are indeed transcendental, spiritual, or metaphysical experiences? Certainly not if we use our brain technology, simply because our brain technologies simply tell us what we observe in the here and now using matter as an explanation. However, the very fact that those areas respond, the very fact that those areas respond in a way that seems to be the best way for those manifestations, as in perception, to be represented in the mind of the experiencing person, gives the general idea that it's really hard to make the claim that we are indeed only our brain. Thank you very much.
Thank you very much, David. That was an absolutely fascinating report. And that was surprising that your speech was very much a tune or consonant with other speeches today, which were in Russian. It's a pity you couldn't participate in our first section in Russian.
I'm so sorry. Yes,
Definitely
it's.
miss you.
Thank you very much. Hopefully, maybe we'll have it.
Taking into account the time difference, your report is a heroic action or heroic deed. Certainly, we do appreciate it very much.
Thank you very much.